Algebra 2. Alright, you ready? Yeah? Yes? Okay, look at the top. There are 3 properties we're going to review. You learned all of these in Algebra 2, hopefully, maybe. Okay, the first one is the exponent property. When you have an exponent in a log, do you remember where the exponent can move to? Okay, if you have like an x up here, you can move it down to the front. Do you remember that? So that's the same as n log b of x. So you can take the exponent and you can pull it down from the front. Now, all of these rules that we're going to learn, you can also do backwards. So if the exponent started in the front, you could also move it up. Okay, second one is the addition property. Then after addition, what do you guess comes next? Subtraction. Very good. Okay, so addition property is next, then subtraction. Okay, do you remember, get out your Algebra 2 brain, what do you do when you have logs that are added? Multiply, good. And what do you guess you're going to do when they're subtracted? Divide. Very good. So here, you're going to have log little b. If it was x plus y, it's going to be x times y, or xy. Okay, then subtraction, like we just said, when the logs are subtracted, you're going to divide. It's called the arguments. Okay, so that would be log little b of x divided by y. Okay, so all 3 of those you should have already learned. We're just going to solve with them today. Now, you can only combine logarithms that have the same base. Okay, so if the little number's different, you cannot use any of those rules. So, for example, take a look at number 1. I have log base 3 of 8 plus log base 3 of 5. Well, then the addition rule tells me that if I have 2 logs that are added, I can multiply their arguments. So if I do 8 times 5, what am I going to get? 40. So that is equal to log little 3 of 40, because I would have done 8 times 5 combined into a single log of 40. Make sense? Okay, look at number 2. I have a plus in the middle. If my logs are adding, which property should I be using? Okay, I should use the addition one if the bases are the same. But what are my bases? They're different. So for this example, I would say different bases cannot combine. Okay, so you cannot combine those because they don't have the same base. If that doesn't match, you can't use any of those rules. Okay, go down to number 3. I have log little 3 of 14 minus log little 3 of 2. What rule should I be using? Addition or subtraction if that's a minus? Okay, addition's for adding, subtraction's for minus. So if it's a minus, what am I going to do with my x and y? Divide. So I'm going to take the 14 and the 2, and I'm going to divide. What is 14 divided by 2? So that's log little 3 of 7. Make sense? Next one, number 4. We have log little 3 of 20x minus log little 3 of 5. What do I do with the arguments? Divide. Very good. And if I do 20x divided by 5, 4x. Very good. So it'll be log little 3 of 4x. Make sense? Okay, next one. The first thing that I want you to pay attention to on number 5 is that you have a number in front of the log. That is the exponent rule. So I'm going to come up to the exponent rule here and point out that whenever I have a number up top, it can move down to the front. Well, then the same is true of the reverse. If I have an n in the front, I can bring that up and apply it as an exponent. That's what I'm going to do with the 20 on number 5. So this 20 is going to come up and be a log little 3 of x to the 20. So I have log 3 of 3 plus log 3 of x up to the 20 because I use my exponent rule. Then from there, if my logs are added, what does my addition rule say I need to do with the arguments? I need to multiply. What is 3 times x to the 20? 3x to the 20. You just put them next to each other. Okay, so I'd have log little 3 of 3x 20. Make sense? Okay, next one, number 6. What number do I have to move right off the bat that's in the wrong spot? 4. When I cross out the 4, I'm going to apply it as an exponent on the y. So you can put a little arrow to remind yourself those numbers in the front jump up. So I have log little 5 of 10 plus log little 5 of y4. And then from there, I notice it's a plus in the middle that tells me to multiply or divide. I need to multiply these two. And when I multiply 10 times y4, what do I get? 10y4. You just put them together. Okay? So I'd have log little 5, 10y4. And then keep in mind that if those weren't log little 5s, both of them, you couldn't combine them to begin with. Okay, 2 more left like that. Look at number 7. What number can I move?
7.
The 7, where does it go? Up as an exponent. So I have log little 6 of 2 plus log little 6 of 7 minus log little 6 of 3. Now, what you're going to do from here is you're going to take turns combining them. So I'm going to combine these first two together first. I see a plus in the middle. Am I multiplying or dividing the 2 and the x7? I'm going to multiply. So 2 times x7 is log little 6 to x7. But then I have a third log, log 6 of 3, that is minus. And if it's minus, how do I combine those two logs? I'm going to have to divide these two. So I'm going to have 2x to the 7 divided by 3. Now, question, can I simplify anything with that? Okay, 2 and 3 can't divide, so that would be my answer. Log little 6 of 2x7 over 3. And that would be your answer. So if you can divide, totally do it. But if you can't, no worries, you just leave it alone. Okay, one more like that before we start solving. Look at number 8. Is there anything that changes the order on number 8 that I didn't have on number 7? These parentheses tell me that instead of me going left to right, combining those two and then combining that one, I need to do these two first. So parentheses change your order to where I have to do that first. Remember PEMDAS. Now, before I can combine them, I have a number in the front of a log that has to move. What number is it? 5. So cross out the 5, put it as a power. And so now I have log 2 plus log x5. What do I do with their arguments? Multiply or divide are your choices. I see a plus in the middle that tells me I'm going to multiply. And what is 2 times x5? 2x5. Perfect. So I have log 2x5, but then remember in front of that I had a log 6 of 10. So after I combine the parentheses first, now I need to do the subtraction. What does subtraction tell me to do with these two? To divide. And remember your order, you always put the first log on top. So that's going to be log little 6 of 10 divided by 2x5. Now, is there any part of that fraction that can reduce?
Yes.
10 and 2 can both divide by what? 2. So if I divide by 2 on top and I divide by 2 on bottom, that would give me 5 over 1x5 inside the log though still. Okay, so I'm going to put there reduce. Okay, but technically the first one's not really wrong. It's just not simplified all the way. So if it was multiple choice, you would need to know that you can do that. Make sense? Okay, so when you're ready, turn the page and get out your chart. If you have your yellow sheet from Friday where you guys took that little quiz, there's another chart at the bottom of that if you lost your notes. Okay, but I'll grab one to put up here. So it's at the bottom of this sheet. So we are looking at number 9 on the back of the notes. Okay, first thing I notice is that I have 2 log terms. That's not going to work. We need to combine them. If it's log base 2 of 8 plus log base 2 of x, what do I do with their arguments? Multiply or divide? Multiply. What is 8 times x?
8.
Log little 2 of 8x. Okay, now once you get it down to 1 log, you can do a loop just like we learned last week. So where does my loop start? 2 up to the 4, bring it back around, equals 8x. And then from there I can look at my chart. 2 to the 4 is right here. 2 to the 4 is 16. So 16 equals 8x, then what's my next step? Divide by 8. 16 divided by 8 means x equals 2. Good? Okay, number 10 right next to it. I have a number in front of a log. I can't do a log loop with that there. So what do I do with the 2? Move it up to the top on the x. Very good. Then from there, I have log little 3 of x squared equals 4. Huh? Well, we used our chart, so 2 to the 4 is in the chart here. It's 16. That chart we had from notes 8. Okay, then from there, where does my loop start? 3 up to the 4, bring it back around, equals x2. And then this is where you can use your chart if you have it. Okay, 3 to the 4 is here. 3 to the 4 is 81. So if 81 equals x squared, what's my next step? Kind of. How do you get rid of a squared? Take the square root. And when you square root 81, you should get 2 answers. What are they? Plus and minus 9. Or positive and negative 9 is the same thing. Make sense? Okay, look at the next one. Number 11, I have another plus in the middle. Plus tells me to do what with these? Multiply. What is 2x multiplied by 4x? Multiplying. 8x what? Squared. So my answer this time is going to end up with another squared in it. So I have log little 2 of 8x squared equals 5. Then I begin my loop from there. 2 up to the what? 5. Bring it back around, equals 8x squared. Then from there you can pull out your 2's chart. I'll put mine up here for a second. What is 2 to the 5? 2 to the 5 is 32. So I'm going to change my 2 to the 5 to a 32 equals. How do I get rid of the 8 in front of the x squared? You're looking in your chart for that number. So 2 to the 5 is 32. You also, if you have a calculator, you could just type in 2 up to the 5, and that would work as well. So divide by 8 from there. What's 32 divided by 8? 4 equals, 8's crossed out, x squared. How do I get rid of the squared? Take the square root. And square root of 4 is 2 numbers. What are they? Plus or minus 2. Good job. Okay, next one, number 12. I have a number in the wrong spot. What number is it?
2.
That 2 in the front cannot stay there for me to combine these logs. So my 2 is going to jump up to be a squared. So now I have log x squared plus log 4. And then I'm like, well, wait, if I have 2 logs, I can't loop that. But if I can squish them together, then I can do a loop. What do I do to combine these if it's a plus in the middle? Multiply or divide? Multiply. What is x squared times 4? X squared times 4 is 4x squared. Good job. Okay, now notice that on this one the base is missing. What's the base if it's not written in for you? 10. So we're going to start our loop from the 10 that we had to write in. So it's 10 up to the 2. Bring it back around equals 4x squared. And then remember, for the 10 squared, you're looking at your chart or you're typing it into the calculator. What is 10 squared? 100. And if 100 is 4x squared, what is my next step going to be? Divide by 4. Very good. So I'm going to divide by 4 first on both sides. What's 100 divided by 4? 25 equals x squared. Last step, do what? And x is 5? Wrong. What is it? Good job. Make sense? Okay. 13 and 14 get a little bit tricky. So if you started looking at the homework, they're not really tricky, but just watch at least one example off your notes. What do I do when my logs are added? Multiply or divide? Okay, but what am I multiplying here? What are my arguments? The first argument is just an x. The second one is times an x minus 8. What property are you going to need to use there?
Division?
No, like little arrows. Distribution, thank you. So what is x times x? So log little 3 of x squared, and then what about the x times the minus 8? Negative 8x equals 2. From here, I do a loop, just like last time. Where does my loop start? What base? 3 up to the 2. Bring it back around equals. And then I have an x squared minus 8x. From there, I convert my 3 squared back. What's 3 squared the same as? 3 squared is 3 times 3. 9. What do you do from there?
Add 8.
Nope.
So minus 9.
Okay, you are going to minus 9 because what are you going to try to do? T-chart. Yeah? There's an x squared and an x. This is a T-chart problem. Now, 9 is on the wrong side, which might kind of throw you off. But when I bring that over, I have 0 equals x squared minus 8x minus 9. And that is a T-chart. Okay? So whenever you end up with an x and an x squared, that's T-chart. That's all you have up your sleeve for that. So what will multiply to negative 9 and subtract to negative 8? We haven't done this in a while. What are my choices? 1 and 9, or 3 times 3, right? But which of those subtract to 8? Okay, which one do I want to minus, the 1 or the 9? If I do 9 minus 1, I get 8, but I want a negative 8. So I have to minus the 9. So it'll be an x with a plus 1 and an x with a minus 9. Now, if my solutions are the opposite of my parentheses, what will my two solutions be? Negative 1 and positive 9. Very good. Does that make sense? Okay. One more like that. So number 14, we have 2 logs. They are added. What are we going to do with their arguments? Multiply. But I need to do x multiplied by x plus 2. Okay, in order for me to combine those, I need to multiply those together. So what's x times x? X squared. And then what's x times 2? 2x. Okay, now what did I forget that's going to mess my problem up on mine? What's the base supposed to be? 2. So make sure. Okay, if there was a 2 there, don't forget to copy that down because that's what starts your loop. Okay, so from there, I'm going to do 2 up to the 3. Bring it back around equals x squared plus 2x. Okay, then pull out your chart. What's 2 to the 3? Okay, very good. Look right here. 2 to the 3 is 8. So, right before I get to t-chart, I change this to an 8, and then I move it over to be with everybody else. So what I'm t-charting is actually going to be x squared plus 2x minus 8. And that's where you break off into a t-chart. Does that make sense? Okay. So what do I put at the top of my chart? Positive or negative 8? Negative 8. What are my choices to times to 8? I can do 1 times 8 or 2 times 4. But if I want to have 2 left over in the middle, which of those subtracts to 2? Negative 2 and 4. So I'll have an x minus 2 and an x plus 4. But if those are my x's, what are my actual answers? Positive 2 because I switched the sign, and then negative 4. Make sense? Good. Alright, 2 more left. 15 and 16. You'll notice that both of those don't have a plus in the middle. These are the first ones we're doing that don't have a plus. So if it's a minus in the middle, what do I do with these two guys? Divide. So I'm going to have log little 2, and then I need to divide x plus 12 by x minus 3. Now, question. Can I really divide those? No, so just leave it. From here, what's my next step? I do my loop. Where does my loop start? 2 up to the 4, bring it back around equals. Yep, your little fraction. And then from there, I have to switch my 2 to the 4 over. What is that the same as? 16. Okay, from here, what are you thinking to solve? What could you do? Yep, you're gonna cross multiply. Remember how to do that? Now, 16 is a whole number, but what can I put it over so I can cross multiply? Put it over a 1. And then from there, you're going to multiply the diagonals. Okay? Now, you'll only have to do this cross multiply step if you end up with a fraction like that. Okay, so from here, I have 16 times x minus 3. And then I have 1 times x plus 12. And then from there, you'll just keep solving. So let's times the 16 in first. What is 16 times x? We're distributing here. 16x. What is 16 times minus 3? That'd be negative 48. Okay, then on the other side, I'm timesing in a 1. Well, 1 times x is 1x. And 1 times 12 is 12. What's my next step? Got x's on both sides. That's not going to work. So we want to bring the baby to the mama. So we're going to minus the x here, minus the x here. What is 16x's if I take 1 away? 15x minus 48 equals 12. Then what's my last step after that? Add the 48 across. What is 12 plus 48? 60. And if 15x is 60, what's my last step? Good. And 16 divided by 15 is 4. Good job. So you'll notice that your homework for today is pretty short, but it's because they kind of take forever, right? Okay, number 16. How do I start it off if there's a subtraction? Divide. So I have log little 3. And then I have to divide x minus 2 over x plus 8. Now this time, my exponent on the other side is negative. So hopefully you remember how to do it, but if you don't, we're going to review it right now. So where does my loop start? 3 to the what? Negative 2 equals. Then I bring it back around and I get my fraction x minus 2 over x plus 8. Okay, what do I do when the exponent's negative? Do you remember? You turn it into a fraction. So, 3 squared is how much? 9. Then 3 negative squared is 1 over 9. You remember that? So this is really 1 over 9 equals. Okay, and then I'll put a little note here. Negative exponent means fraction. Okay? So if it's a 3 to the negative squared, that's really a 1 over 3 squared, which is 1 over 9. So I'm going to rewrite that down here. I have 1 over 9 equals x minus 2 over x plus 8. Well, then what do I do in that case? Just like last time. Cross multiply. So I'll have 9 times x minus 2 from this diagonal. And then I'll have 1 times x plus 8 in the other diagonal. Now, if you can do this first step in your head, that's totally fine. What's 9 times x? What's 9 times minus 2? Minus 18. Then on the one side, 1 times x is 1x. 1 times 8 is 8. What's my next step after that? Bring the baby to the mama. So minus the 1x over. What's 9x if I take 1 away? 8x minus 18. Then what do I do with the minus 18 to cancel it out? Add the 18 across. What's 8 plus 18 more? So 8x equals 26. Last step. Divide by 8. Will 26 divide by 8 evenly? Then you can just leave it. Now, that actually can reduce. It'd be 13 over 4. If you want to change it, you can, but you don't have to. Okay? So, there's one off the homework that I just want to make sure you understand is the same as that. Pick one of the ones with the subtraction and we'll do it together.
8.
8 is really similar. I was thinking like 2 or 3.
Yeah.
So why don't you do number 3? So just set it up first. So off your homework, look at number 3. Okay, you only have 8. What is step 1 on number 3 when I combine those logs? Do I multiply or divide? I have a minus in the middle, that means I divide. So I'll put 4x minus 5, divide by 7. Then from there, where does my loop start? 2 to the 3, good job. Back around equals, and then the little fraction-y part. So 2 to the 3 equals 4x minus 5 over 7. Then I gotta switch this guy back. I can't leave that as a 2 to the 3. What does that turn into? 8. So I have 8 equals 4x minus 5 over 7. What do we want to do at that point? Turn it into a fraction. 8's not a fraction, but how can I turn it into one? Put it over 1. And then from there, you're gonna do what? Cross multiply. So it's the same type of thing that you were doing before, you're just not going to have x's in both parts of the fraction. So what's 8 times 7? 56. And then on the other side, what's 1 times 4x? What's 1 times minus 5? And then from there, just keep solving. So what do I do with the minus 5? Plus it across. Negative 5m plus 5 cross out. What's 56 plus 5? 61 equals 4x. What's your last step? Divide by 4. Will 61 divide evenly by 4? No, so just leave it. That's good enough. Now, if you want to divide it out in the calculator, that's fine, but you just don't have to. Okay? So, if it's a minus, you're dividing. If it's a plus, what are you doing? Multiplying. Okay? The two that you're going to end up doing T-chart on are 5 and 6. So if you want to put little T's on that just to remind you. Okay? Then the other one the other class asked me about was 7. Set up number 7 for me real quick. What should your first step be on number 7? Are we multiplying or dividing? We need to divide 6x squared by 2x. What's going to be left over? Well, you have to divide though. So it's 6 divided by 2? 3. And then if I have x squared, but I divide an x off, is it still squared? No, it's just a regular 3x. Then also notice on that one that your base is missing. Then what is it? A base 10. So you'll have to write in your own little 10 there. And then from there you'll go 10 up to the 2 equals 3x. So you'll start here to the 2 equals 3x. What would you do from there? 10 squared is 100. Good. And then if 100 equals 3x, what's your last step? And then 100 doesn't divide evenly by 3, so you can just leave it like that. Or divide it out in the calculator if you like that better. Make sense? Okay. Good job. So you just have 6 left. And then who said they were gone Friday? You? Oh, Z.
Good afternoon, students of L.B. Berkner High School STEM Academy. Students, if you are interested in trying out for softball, please meet after school in room B102. Thank you and go Rams.
No questions. That's a minimum. So you're looking for a negative. Yeah. Doing okay? Yeah. Yeah. So you do 16 times x is 16 equals. Minus, oh, hold on, minus 16. You have to times it. And then 1 times x is got it from there? Yeah. For the first one? Hey, thanks. Okay, so you're talking about 1? Okay, so if it's a plus in the middle, you're multiplying. So if I were to do 2 times x minus 2, sorry, what would be left over? 2x minus 4. And then from there, you just do your loop. So you'd have 4 up to the 3. Bring it back around equals 2x minus 4. And then on your chart, 4 to the 3 is 64. And then from there, you just kind of like keep solving. The one thing you have to be kind of careful for is like on number 4, when you're multiplying 2x and 4x, that's going to be an 8x squared in the middle. So when you loop it, make sure you put the square on there. Yes, ma'am. Want to check it?
Yeah, essentially rest out of it. She have to, if she doesn't take her car, she's going to like this.
When you're done checking.
No, take the bus and go to the train station. Me, the train station next to me, she just drive to the train station.
Yeah, I have B-lunch still.
So if you have B-lunch, I have
The
calculus.
train station is right next to me.
I keep trying to come in to take that test, but I think you got it.
If I want to go there, it would be easier for me to drive.
Yeah, we can just have a parking space, unless if they have student parking space, that's what I'm going for. But if they don't have student parking
Okay,
space,
so tomorrow,
I'll drive my vacation.
Just 5 by 5.
Or you can watch them during lunch.
Yeah, that's
Because your notes are never long enough that you couldn't watch them just during lunch.
Okay, cool.